Hello everyone, welcome back to an Altium tutorial. This one we're going to follow up to our previous one where we designed the schematic symbol for a new part, and this one we're going to make the footprint for it. So, I'm Jonah, I'm joined by Chris,
Hey there.
and shall we dive right in, Chris?
Yeah, let's dive right in. So I got Altium up on my computer. You can see I currently have this blank PCB, just some writing on it. So I'll hit 2 to go back to 2D view. Uh, so what we're going to do is basically we need to create a new library for our footprints. So I'm going to do it the same way that I did in the last tutorial. We'll right click on this. This is my project. Add new to project. And then I will say a PCB library. But I've already done that, so I'm not going to do it again. And then I'm going to open that file. And when I do that, I'm going to be here. So this is a blank screen. I have a tab on the right. If you don't see this tab, just click Panels, and it should be PCB Library. You can open that. So this is a list of the footprints that are in this library, and this library is specific only to this project. So if you start another project, you're going to have to either make a new library, or like we did last time, you can say File, New, Library, and integrate a library. And if you do that, then all the projects in the group are going to have access to these footprints, just so you know. Um, so yeah, let's start. So what we're going to do is we're going to make a footprint for that LED, which we made a symbol for last time. So here's the datasheet. And if I scroll down to page 3, we can see all the information we get about the actual package. So most data sheets, or at least some data sheets, will give you a little more than this. They'll give you some measurements. They might even give you a recommendation for how to design your footprint, which you should follow if you have access to it.
And
But in this
also
case,
read
we
the
don't.
application notes. So if
Yes,
often they'll say, hey, we were a little wrong in the data sheet, but in this application note, we'll say, you need extra VOs or something like that.
exactly.
But here, we don't have
So
any of that, right?
exactly, we don't have any of that. All we get is a picture of the back of the chip, and we can see this picture's a little confusing because all these pads are kind of different sizes. Does that mean that our, solder pads have to all be different sizes? The answer is no, they don't. We actually are going to make sure they're all the same, because it'll make it easier to design and it'll make it work better. So let's start by just maybe defining, the region that this chip is going to take up on the board, so we can kind of see how big it's going to look and kind of do it like that. Um, so some things we know about this chip. It is 3.5 by 3.5 millimeters. You need to check to make sure right here all dimensions are in millimeters. Yours may be in mil, which would be imperial, so you want to be careful about that. So we're going to switch to millimeter. Right now, Altium is in mil. You can see right down the bottom left corner here, I'm getting measurements in mil. So I'm going to do is hit Q. Oh, I got to click. Okay, well, I'm going to hit Q, and then you can see now I'm in millimeter. And also my grid, I hit G. I want to make sure that I'm using a millimeter snap. Right now I'm going to do 0.1 millimeters.
So might I suggest 0.025? And
Yeah, that's actually a good suggestion.
so where I'm getting that suggestion for viewers at home is if we look on the data sheet, the smallest resolution used or smallest distance used to define anything is 0.01, I believe, because we have
Uh,
0.05. So 0.85, that's the smallest resolution. Now I'm suggesting half of that because we're going to have to define things that are aligned to half of that width, as we see later.
right. Um, the only thing I would say is can we use a coarser grid snap just to define the edge and then switch to a finer one after that?
Oh, of course.
All right, so let's do that. But I'm still not going to use 0. 0.1 like I said. Oh, okay. Yeah, this will work. So, what would you think is the thinnest we should make a top overlay? And actually, is that information given on the JLC website?
Uh,
Assuming that we're using JLC.
they will, so your manufacturer will give you a minimum thickness for your silk screen, and you can go and check that on the website. Shall we do that, Chris?
Sure, I've already got it up.
Awesome.
So this is going to be, where am I looking for here?
Um,
Yeah, Legend.
yeah,
They call it Legend.
that'll vary from
Minimum line
manufacturer
width.
to manufacturer. So even though they specify a minimum line width, that's generally for a like straight piece of silk screen. So often when doing text, you want to go a little thicker and a little bigger because there's curves and complex geometry in text, and often the minimum won't be resolute enough to print your text well. I tend to go with
Right.
zero point 0.3 to 0.5 millimeters when doing an outline for a chip.
Let's choose 0.5 because I think it'll make our math a little easier, and you'll see why in a second. So here's the thing. What would be nice is if when we put the chip on, the silk screen, like the definition of the edge of the board, was completely covered, right? So that you didn't see, some of these notes that we're making now to help ourselves. And it would also tell you that your chip is aligned.
Mhm.
So we're going to draw a square in a second, and what we'd like is for that square to be completely covered. That means that we're not just going to put a line that is, we're not going to do basically start a line here. This is on the wrong layer, but you get the point. And then go 3.5 millimeters because it would extend actually beyond 3.5 millimeters, right?
So
Altium says
we're gonna move it a little
this
in.
is 1 millimeter. Yeah, exactly. Altium says this is 1 millimeter long, but if I measure from the outer edge to the outer edge, it's actually more because you have this distance right here. So we need to do some math. So let's switch to the top overlay. Let's grab the line tool and let's press on our origin. I'm going to hit tab, and then we can see my line width is 0.5 millimeters. That's exactly what we want. Okay. So what does that mean? That means that from the origin to the left boundary, right, of this symbol right now is half of 0.5 millimeters, which is 0.25 millimeters. So I need to make sure that I have a grid snap that can achieve a 0.25 millimeter resolution. So I'm going to go in here. 0.25 is right there. Perfect.
You go.
So now when I go to start a line, instead of starting it actually on the origin, I'm going to go 1 over and start it here.
One up as
And,
well,
and actually,
Chris.
I need to go 1 up as well because we're doing a square. So there we go. Let me zoom out a little bit. Now I need to go out to, right, quick way to do this is to go out to 3.5 and then go back 1. Cool. Now I need to go up to 3.5. You can see, so right now, by the way, I'm using the bottom left corner again. You can see my X and my Y measurements. That's what I'm using to reference this. And then go back 1. And then, you need to click twice for a right angle. My mistake. And then we're just going to complete this square.
So, Chris, I noticed your origin is in the bottom left of your component. Does it have to be?
No, it doesn't have to be. That's a great thing to point out. You can actually move the origin at any time, and you should be moving your origin because it will actually save you a bit of work. So for example, if I hit E, and I go to set reference, I can actually say location and put it wherever I want it. And we're going to be using this. So the next place I'm going to put it is actually right here in the middle. And you'll see why coming up. We'll be thankful that so now this is 0, 0, right? This is negative x, positive y, and negative y. And that'll make defining our pads a little easier.
That way
So
we
let's
don't
make
have
sure I did
to
this right.
add offsets to everything. Also, are you able
Exactly.
to use... Is this similar to other editors in Altium, or is it specialized?
Yeah, that's another good thing to point out. This editor is actually just like the PCB editor. So most things that you can do in the PCB editor, you can do right here. That includes placing pads, vias, text, lines, right? All of those tools are still open to you the same way they would be. All the navigation is the same. The only difference is that this saves itself as a footprint that you can reference in other places. So let's make sure I did this right. If I hit Control M, I get a measuring tool. And if I put it on this edge, right here, and then I go over and put it on this edge, my distance is 3.5 millimeters. That's perfect. Now let's do this one. And 3.5. Okay, so the outer edge is correct. If I hit Shift C, I can clear those measurements, and we can continue. So let's talk about pads a little bit. So how are we going to define the size of these pads? Because we're not actually told what's going to work.
And they also
So
don't...
what do you think?
So, I think there's a couple things to take into consideration. First, I don't think we need our pads to actually touch the weird shaped pads on the bottom of the chip. I think we only need to touch the straight sections.
Right.
Now, we don't know exactly what that is, but we can estimate, or if you have one in front of you, you can measure. We did this ahead of time, and it's going to be about zero point 0.5 millimeters in. Or, yeah, zero point 0.5 millimeters in. Um, so we want a pad to straddle the outside edge of the chip. Um, and that's one thing to take into account. The other would be how are we going to solder this? So why don't we proceed as if we're going to refill this, which means we don't need a lot of extra pad outside. And then if we want to do hand soldering, we can make the pads a little longer. How does that sound?
Cool. Yeah, sounds great. All right,
Um,
so let's do that.
we also need to take into account
So,
pad height, which, well, let's reference the data sheet for that. We'll just make it a little taller than the exposed pads.
right, what Jonah means by that is right here, 0.85. We want our pad to be just a little bit bigger than that so that it's a little bit easier to seat this chip. If there's some margin for error is what we're trying to do. But let's start by finding 0.5 millimeters in, right, which is how much we want to go. So if I hit
Chris, we want to
Control
go right
M,
on the edge, right? Because that's our edge of a part.
I just mean like 0.5. Hold on, you'll see what I mean. Right there. Right, so that's actually obviously we made our silk screen 0.5 millimeters thick. So we want our pad to terminate on this back edge. And that should be enough to get a good solder. And then how far out do we want to go?
Let's go the
Not too
same
much.
widths.
So we can say, again, 0.5 out. Right, so we need a pad that stretches, from this X to this X. And the height, we said 0.875.
Yeah, so
Cool.
we're just adding a little bit on each top, on
Right.
each side. Yeah.
All right, so let's do it. So right here is our, pad tool. If I press that, I get this. That's not what we want because we are still in the top overlay. So if I hit Tab on my keyboard, I can go into Properties and set this to Top Layer. Where are you? Scroll up, Top Layer. And we're going to set the designator to 1. You can see there's a purple edge around this. That purple edge actually defines, all right, so they're going to put the solder mask on your board, right? That's the color, like the green color or whatever color you choose. And that prevents you from just, putting solder everywhere. You only get to, it covers the things that you don't want to solder to, and it leaves exposed the pads. The way that they put that solder mask on usually is a photolithography process, and that mask can move a little bit. There could be misalignment with the template, but more likely there's actually some expansion. So Altium tries to basically predict that expansion with some typical numbers. I think it's like 4 mil or something like that. So this edge is where they're actually going to define that mask to, and then when they do the photolithography process, Altium anticipates that the solder mask will expand inwards, and that's why we have this like little region here. So that's not part of the pad. This purple is not part of the pad. Only the blue is part of the pad. A little bit of a long-winded explanation, but it's not totally essential. Just want to make sure that makes a little bit of sense. All right. So if I hit Tab, I actually already have done some of this stuff before. This is not our first time recording this tutorial. So we have set right this Y here. That's okay. So you're going to go in here and you would type 0.875 millimeters. And right here, we're actually going to change this number, right? Because we want it to be just 1 millimeter. Cool. Okay, and some other things I want to point out. So you can actually have other shapes too, right? So if you said, maybe you said round or something like this, you could set this to a circle, and you can set, instead of saying top layer, you could say multi-layer. Now you have a through-hole part, so this would be a good way to make custom through-hole parts, stuff like that. You don't have to necessarily use this to make SMD parts. So I'm going to choose top layer rectangular for this specific part. Cool. Okay, so we said we want this back edge of the part to be on that line. Cool. And that will actually line it up, and we're going to do 2 of them, but what we're going to notice is that these Y's are not aligned. For example, whoops, let me delete that. These are not centered with the part, and they should be centered with the part. So how do we fix that? All right, so the datasheet tells us that these should be 1.75 millimeters apart, the center to the center. So that's actually a really useful number. What that tells us is that since our origin is put in the middle, if we go put this, so this is the X and Y position, if we put this Y position at 1.75 divided by 2, and we put this one at, let me click it, negative 1.75 divided by 2, we're going to have what we want. Cool. So a quick way to do the other part of this is to select these, copy them. You can just, copy from this pin. You can hit V and then put them right back where they started. And what you're going to do is set the X position right now you're just going to flip the signs to make it positive x. And that reflects them over the origin and puts them on the right side. You do have to change the designators. Let's match the datasheet. Make sure that your designators line up. So this should be 3 according to the datasheet, and this should be 4.
And are those
And there we go.
designators like pin numbers?
Yeah, basically. So I'm looking at the datasheet here, and this is 1, 2, 3, 4 right on our pins. I want to make sure those line up because in our schematic, that's what we use to number these, right? So we made sure D out was 1 and VSS was 2 and ETC. So those have to line up.
And your top layer is blue.
Yeah, my top layer is blue. Sorry, I always forget to mention this. I've changed my colors because I think that I like the way they look a little better. It's really easy to do. If you go into your view configuration panel, you can set these to whatever colors you want them to be.
Mm-hmm.
That's why my top layer is blue and my bottom layer is orange. It really doesn't have any effect on the design. So we want to do a couple more things. Let's give this a name. So we're gonna call this what's this thing called? It's called like the SK. Here we go. Well, let me put this in front of the screen. SK6812 Mini. Nice. Alright, so now it has a name. Another thing we want to do is make sure that we have some indication of which way it should go since it's symmetrical.
Mm-hmm.
And luckily the datasheet gives us this. So you see this little corner here is like cut short, it's a chamfered corner. We're going to copy that so that you can line those two things up and make sure that your chip is always pointing the right way. And it's easy to do. Usually you would just grab a corner like this and go in. There's a couple other ways to do it.
Chris,
there's a reason that's not going to work. Because we're not gonna have a. We'll get to this in a second, but we're not going to put silkscreen over a pad. That would not work. So the other way to do this is to go to your line tool, and just put a dot right there. Whoops. I think you gotta use the circle tool for this. So click and hold, and I get full circle. And yes, it's in the wrong layer. We're gonna fix that. So if I go here and hit tab. Let's just go into properties. I want to move this to top overlay. And then if we make the width of this line thicker than the radius, say like 0.5, it actually fills in. It can actually be smaller than that, I think. It can be 0.25. Nope, I was wrong. Let's just increase this until it's actually filled in.
will be
maybe
0.5.
it really is 0.5. Yeah, it will be 0.5. My mistake.
And as a small warning for anyone who has enough room to do the notch that Chris showed, make sure that your notch will fit your minimum printable differences. So we might even want to go a little more in for the chamfered corner, just a touch.
Right. You might do it like that or something.
Yeah, like that.
But like I said, we can't really do that so well because we can't have writing going over our pads. That's not going to work.
They won't.
So how do we fix that? Right, they won't produce that. So we're probably not going to get to use these lines, or if we are, we're going to have to adjust them significantly.
I'd say let's make them shorter so that we have horizontal alignment.
So you want to put them in the middle between the pads?
Ideally. You don't have to, but I think it would make it easier and less prone to error if you can see it. Although they might not even print
Alright, an efficient way to do that is to actually start a little bit of a chamfer, like this. And then just delete the chamfer segments. That way you break the connection between the horizontal and vertical. And then you can start dragging them in. Right, so this, we're going to change our grid in a second to make this a little better. Right, so that's no good. So let's hit G, let's go to 0.025. Now I can very finely move this. One thing the PCB editor is not going to do is check your rules, because there are no rules, obviously, when you're designing a part, because it's not a PCB. But the PCB editor will retroactively check them. So let's say I do something here that can't actually be manufactured. I'm not going to know until I go to place it into a PCB, and then it's going to tell me this part's not manufacturable. So there might be a clearance issue here or something like that that I won't know about.
And the only way to check that
Okay.
is to add it in, or can you run?
Right, is to put it into a PCB.
Only.
I don't think that you have access to rules when you're in here.
Okay.
But you can edit the footprint in the PCB without having to necessarily go back to the library if you want to.
We can make a bite
Let's copy
size for
this.
that, and we'll show you later.
Yeah, that's a good idea. We can copy this. I'm going to copy it from the center of it, just like I did before. I'm going to paste it right back in the same place, and then I'm going to flip the X position. That will reflect it. Whoops, that's the start, and I need to flip the end as well. With a line, you gotta flip the start and the end. Cool. And in doing so, I've reflected it. And then we can do these ones. Let's just go like maybe 3 clicks in from the corner. I'm using my arrow keys to do that. 1, 2, 3. And then the same thing up here. Let's reflect it. So click this, copy from the middle. There's some confusion I've noticed in helping some teams with what that does. Let me just quickly say Control C to copy. Then this is our copy reference. So if I copy from the middle, I will also paste from the middle. If I copy from the edge, I will paste from the edge, right? So you want to think about that while you're copying. So copy from the middle, paste back in the middle, and then flip the sign of the start and end Y. So this is going to be positive start and positive finish. And we have reflected this. Awesome. Cool. I think this could be a little smaller. Let's set the width of this to 0.25, and then we can also reduce the radius to 0.125. Did I do that right? No, I did not do that right. 0.25. There we go. Okay, so it's a bit smaller. We can just put it somewhere like that. Cool. So usually this dot goes next to pin 1, right? So this could be a little confusing. What do you think?
Yeah, so rule of thumb standard is dot goes next to pin 1. However, we looked at the data sheet, and we have some in front of us. So we know that even though that's labeled pin 1, the dot goes in the other corner. This is very unusual to see, but it's something you might encounter.
Right. Yeah, that's a little bit confusing, so you got to be careful. And there are some other things you can do. I've seen other things that actually go, let's hit tab, let's say. I've seen some people add text to their board, and they just like very clearly write 1, which is, that's pretty hard to mess up. It's kind of a safe bet. That's maybe a little too small.
Though in our case, if we have both, that could be quite confusing.
Right, that could be confusing. It's kind of up to you to decide how to do it. I would go with the data sheet in this case because we have that chamfer in the bottom corner. We're going to put our marker in the bottom corner as well. Just make sure you keep track of these things. So what else can you do? There's a couple other things you can do. You could define the outline of this in an assembly layer. You could use the component center layer. There's a bunch of things you could do. I think that's pretty good for this tutorial because this is really all you absolutely need. So I want to move on to showing you how to actually use this. So let's go back into our schematic library. I'm going to double click this and open it up. And here it is. Perfect. So all I got to do is say add footprint right here. And I get this. And I'm going to browse for it. And here I am. So you got to make sure you save before you do this. Make sure you save what's in that library so that your schematic symbol library has access to it. And if you do that, you should see it right here. I should have PCB Library. It's just what I named it. I say OK. Now I have this. Then I go to pin mapping and I make sure this is right. Obviously, it's going to be right because we named them literally the same thing. But if in case there's a discrepancy, you can make sure. So the component pin and the model pin. So the component pin is the schematic library. The model pin is the footprint library. 1 to 1, 2 to 2, 3 to 3, 4 to 4. Perfect. OK. And OK. And there it is. It's right there. Let me hit save again. And that's it. So if I've saved it, I should be able to go into either my schematic or my PCB. I can go in here to panels, components. I should be able to say schematic library, NeoPixel, right click, and place. And there it is. Very nice. And it even has a designator because of the work that we did in the schematic library. But I don't have to show it. I could go into properties and I could actually hide it. if I wanted to. Although you probably shouldn't hide your designators. You should just change them to be more relevant. For example, SOIC-19 is not a good designator for an LED. It should probably just say LED. But I think we've covered in depth how to set proper designators. So yeah, I think that's it.
This should be the very basics to
Cool.
get them up and going, and we'll see you in the next one.